continue from previous video where we calculate I effective beam 2488 times 10 to the power 6 millimeter power 4. Now we need to check the length between the support is L equal to 6800 millimeters. So if I can show it to you here, the length between the support is 6800 millimeters. That is the length of the beam. So now for that case, let's say N-Rosten coefficients. If I want to calculate the N-Rosten coefficients for all interior columns. So these are interior columns, and that are the exterior columns. So these are all 4 are interior columns, 2 are exterior columns. Now in that case, for all interior columns, if you want to calculate the N-Rosten, let's say this N-Rosten psi 1. So that psi 1 is basically it's here. So we are going to calculate N-Rosten at this bottom of the let's say this grid C. So we are calculating here psi 1. So that is the columns we are interested, that is the beam. So it's interior column. So if you have an interior column here, this is the beam that I draw the beam here, this is the beam here that's I draw, that's the columns continue from this floor to this floor. So it has given the equation sum of the moment over length for the columns over beta moment of inertia over IL for beam. So 5760 times 10 to the power 6 for the columns. I think we calculated that one in the last videos. Let me find that details. So here you have 5760 times 10 to the power 6, 5760 times 10 to the power 6 that we calculated for the columns that we done it in the last video. Over 3200, that is the length of these columns that is given here, 3200 meters. So that is from this end to this end, that is so on here. Plus so there are for that cases the columns are 2. So we have 2 columns. One column is this one and another column is this one. So at this particular joint you have 2 columns. So at this particular point you have column 1 that is coming from this storage. So that is these columns and this. So if you are talking about this point, you have these columns and these columns that we just take into account. So you have 2 columns at this particular joint. So the same moment of inertia for, let's say this is for bottom one and this is for top one. So same moment of inertia and same length are given here. Divided by beta we calculate, we see that fixity factors beta equal to 1. So I substitute beta equal to 1 times by this moment of inertia for beam. So one beam on the left side, one beam on the right side. So 2488, let's say this beam here, 2488 times 10 to the power 6 over the length of that beam is 6800, that is so on here, plus 1, that is beta. So that's that is for this beam, and that's another beam is exactly the same that you are showing here. If you simplify that, gives 4.9 as a fixity and fixity constraint. So that is here at this particular point. Now we're going to follow exactly the same procedures for the points here. Now your columns point is the N-Rosten we need to calculate at this particular point. So in here you have 2 beams, you have 2 columns. Okay, so for 2 columns you have 5760 times 10 to the power 6 is the same thing, because for these columns as well the same moment of inertia and same length. So same as here, 5760 10 to the power 6 over 3200, and the second columns here 5760 times 10 to the power 6 over 3200. There is a beam here for this C, beam here. So you have beam here. So you have 2 beams, 1 times 2 4. So it's exactly the same that I just explained you in the previous steps, but now this is we calculated this N-Rosten. If you have different length of the columns, different beams here, you would have different gamma 2 N-Rosten. Now that is 4.9, exactly the same that you done it in the last steps. We done 4.9. If you know this 4.9, that effective length factors K, that you can calculate from figure 10.5.3c, and there is 2 figures. two figures, meaning there is a one figures here which is B and there is a C, but this one is the braced columns and this one is unbraced columns. So we are in the unbraced columns. Why? Because in the questions it says that it's not prevented, the word written here. There you go, the sway between the floors is not prevented, so that is unbraced columns. So we have unbraced columns. So in that case K2, so gamma 1, let's say this is the there was gamma 1 4.9 and gamma 2 4.9. so in that case let me get the ruler. So 4.9 is almost 5 here, so gamma 1 is 4.1, so that was 4.9 somewhere here. If you draw the line across here and then you have 4.9 here, so that would be more than 2. Between 2.5 and 2.2 you have 2.2 approximately, so you can get this point here, that is 2.2 as a K, which is the effective length factor K. So that's all the values are effective length factor K, so that K equal to 2.2. Taken from here is basically what we calculated, n rust 1 and n rust 2. We can calculate this the K value. For effective lengths, LE equal to KLU, and what is LU? LU is a clear space, clear distance. So if you want to calculate this clear space between the columns, you have 3200 take away 320, this one, so you will find this clear space. So this is the LU. From this point to this point is LU. So 322 take away 300 times by these factors, which is the effective length. Effective length equal to 2.2 times this gives me 336 millimeters, and that effective length for interior columns. So these columns, these columns, these columns, and these columns will be the effective length of 6336 millimeters. Now we're going to follow the same procedures for exterior column to calculate the effective length. Now for exterior columns, which is here, you have exterior column here, you have exterior columns here, so I just draw it up here, this one, and this is beam and columns, and let me extend this one here as well. So there is a columns here, that is these columns here and columns here, and there is two beams. So let me put this gamma 1 here. Now in that case we're going to calculate this first at this joints here, and we have these equations, all the columns meeting at this joint divided by all the beams meeting at this joint. So you have two columns here and columns here, so you have two columns, 5760 times 10 to the we done this one, so exactly the same here, because you have two columns divided by, you can see there is only one beam, so we don't plus this one because we have two beams here, so therefore we plus these two, but here only we have one beam, so we divide by one beam, so that is one beam equal to 9.8. We exactly the same thing that we're going to follow. Let me put that columns extending it here. If I just want to find this at this and or this, and you have this point, so you have two columns here that you can see there. So the two columns 5760, exactly the same thing that we done in just now, where you calculate 9.8. Exactly the same thing, because you have two columns, you have one beam and two columns, so you have two columns which has two columns, and then you have one beam, that is one beam here. I already explained you this 68003200 in the previous step, so it gives me 9.8. So if this is 9.8, again we're going to use the same figures, and gamma 1 is equal to 9.8, gamma 2 is equal to 9.8. So 9.8 is somewhere close to 10. So if you can just get this 10 here, and if you just make it 10 over here, it will be give me the 3. So here 10, 9.8 is 10. So 10 here, and if you just move it 10 here, gamma 1 and gamma 2 is 10. So K value would be 3. Again, effective length for exterior columns is 3, that factors times by this clear space, 3200 take away 320, it gives me 8640 millimeters. So we calculate the effective length for these interior columns, and we calculate the effective length for exterior columns. Okay, we stop here and we continue solving this example in the next video. Thank you.